So today I will quickly hold a presentation and then demonstrate the device, how it operates. So firstly, I will give 2 or 3 slides about reasons for device development. Then I will show some slides about device hardware and device application, which all of these things you will be able to see during the demonstration of device. Then I will show some useful slides about connection to the test object, and then I will compare device with our current solutions. So let's start with reasons for device development. Of course, the main reason for device development is market demand, and listening to feedback of our customers and distributors, we realized that we need multifunctional device with battery. We already have one device, but this device is limited to distributive level, and we will keep it like that. It's a single-phase device, single-phase tester, TWR250B, and it can test both winding resistance and turn ratio, along with demagnetization test. But when we want to apply the same test for a higher voltage level, then we use separate devices. As you can probably see on this slide, we use combination of hardware look similar devices for winding resistance measurement and for turns ratio measurement, but we now decided to combine these 2 devices into one, enable both features of both devices, and on top of that include battery power. So we tried to produce a new device which will be able to combine the main features of our most improved transformer testing devices. And here you can see a list of applications. So pretty much you had a chance to see and experience this with our previous solutions with TWA and TRT series. So resistance measurement of all tap position and in all 6 windings performed in a single test. Again, with our new device, you will be able to demagnetize the core after the winding resistance measurement, turn ratio tests, and excitation current measurement also available. And in first version of TWR250B, you will be able to perform phase angle measurement and automatic vector detection group. Along with that, in later versions, shortly, I cannot promise anything about timesheet, but shortly we will also provide with this device without hardware update, dynamic resistance measurement, heat run test, and magnetic balance test. So it will be only change update on SBC application. No need to return device to our facilities, just update your SBC application. And there will be additional possibility with our device, which will be leakage reactance test. For this device, you will probably need to return device to our facilities for recalibration of device. So this is the list of features available and features which will shortly be available with our device. On this slide, you can see device specifications. So firstly, I will start with test currents up to 25 amps DC, the same as TWA500, our most improved winding resistance and tap changer analyzer. And as I already mentioned, this device will be able to operate on battery, so without main power supply. And in this case, device will be able to inject up to 10 amps of DC current. important parameter is also output voltage for winding resistance measurement. It will be up to 50 volts. Winding resistance measurement range, you can see in this table, it will be able to cover majority of transformers up to 100 kilo ohms. For turn ratio, test voltage will be up to 250 volts AC. The same turn ratio measurement range we could see with our turn ratio testers, so up to 100 turn ratio maximum. And here you can see some information about our battery. So for how long you will need to charge the device from 0 to 100%. It will be up to 2 hours. And in normal condition, we expect the device will be able to operate for more than 4 hours. If you use device on the maximum power, 1 hour with constant maximum power is the limitation of this battery and therefore device. Now you will be able to see some physical characteristics of this device. So pretty much, if you are familiar with DV Power product portfolio, you are familiar with that look. Again, 10-inch touchscreen display, 11 kilograms weighted device. You can see dimensions, and printer will be built in, and it will be part of standard accessories. It's not optional, it's already included in device. To analyze it more thoroughly, our team will of course send this presentation to our listeners, and you will be able to analyze this device and its hardware front panel in more detail. So you can see some things I already mentioned, but there is difference compared to TWA and TRT. This power button, it's not switch, it's just a button. We will have this safety strobe. During the demonstration, I will show how it works, and pretty much hardware you could see with our previous solutions, and I will show in detail when it comes to demonstration part of this device. Now I will provide some slides to get you more familiar with our application. So this application is intuitive. It's easy to operate through this application. Firstly, you select the test object. You can see list of test objects, and in addition to that, auto transformers are also possible and available to test. You can select configuration in this tab, or configuration of three-phase transformer, and you can also select automatic vector group detection, which is part of tests here. So when you select test type, you can select automatic vector group detection, and then the device will be able to automatically recognize the vector group of transformer. If there is a tap changer, you can select it here, and nameplate of transformer can be inserted here. As already mentioned, test types. Here's the list of test types for now. I already explained what can we expect in short future, and it is test options and test current and voltage will be briefly explained in later slides. So this is the opening start menu of home menu of device, and by pressing these buttons, you can operate through these features. So when you can select the test option menu, Dependable of test you select, you will see left hand or right hand side. So right hand side is related to turn ratio measurement, and then you can select whether you would do both simultaneous and sequential test, or we will perform only simultaneous measurement. And with turn ratio deviation pass-fail criteria, you can select mentioned pass-fail criteria, whether is it 0.5% as per standard, or if you want to select something else, but 0.5% is the default menu. On the left-hand side, you can see the display related test options menu related to winding resistance measurement, where you can select if you want to perform high voltage or low voltage winding resistance measurement. Temperature compensation is also available. So these are test options. It's related to selected test. When you press the test current and voltage selection, dependable of the selected test, you will be able to select the DC test current for winding resistance measurement, and selected value can be in amps or milliamps, or value can be customized. Maximum value is 25 amps. For turn ratio test, you can select value of 1 volt, or at maximum level at 250 volts. Regarding vector group detection, as already explained, it's possible to automatically perform the test or select the vector group manually. Here you can see the steps. So firstly, you select high voltage winding configuration, then low voltage winding configuration, and phase shift selection is also possible to select. And if you do not want to perform that, you can perform automatic vector group detection, which will be shown during demonstration. The device can automatically select the vector group. Now a couple of slides about connection to test object. Here you can see that this device with this device you can perform a single connection. So once you connect the test TWR250B to test object, you don't need to remove these cables. On this picture, you can see these clamps. They are really easy to connect to. It's really easy to connect to the terminal. So with these clamps, it's practical on the field. And here you can see zoomed our cables. So the part which connects to the device, it's Neutrik connectors. It's really easier to connect it with these Neutrik connectors than with our previous solutions. Like 2 or 3 years ago, we still use these metal connectors. So this is the improvement from our side. And these TTA clamps are used to connect to the terminals of transformers. For this device, different cable lengths are available. Extensions to these cables are also available. And you can see that different colors are used to make it easier to our customers. And at the end of every cable, you can see the color. So we recommend putting the yellow color to the yellow point and then connect to the phase B. So we always go clockwise here. And now quickly I will compare the new device with previous solutions from DV Power, where you can see our improvement. So at this slide, you can see clear advantage of the left columns over the right column. It's really not fair comparison. but TWRH was our only solution which was able to test both winding resistance and turn ratio test. With TWR250B, we can do the same, but even more practical. As you can see, advantage in almost every category. But compared to TWA 500 and TRT 500, you can see there are still some advantages of the right-hand side, mostly related to the power of device with software, although at one moment this will be equal, but for now TWR250B will have DVTR software, of course, but only for report creating and results reading. With our TWA, TRT devices, you are able to control devices and perform tests using our DVTR. Although all of these devices have this touch screen display, and it makes it really practical on the field and easy to run all of the tests. You basically don't need the software, but it's our one of features for this combination. And for TWR250B, the main advantage will be inclusion of battery, and it's even more practical to use this device because it has only 11 kilograms compared to combination of these two devices, which result in 27 kilograms approximately. Okay, this is the camera which records our device. So firstly, I will try to show everything. So this is our device. It's true, it exists. It's that big touchscreen display, and on the left side you can see the safety strobe. I will later demonstrate the functionality of this strobe. So the device is now turned on. You can see the cables again. You see the coloring matches here: red, yellow, blue, and black. Black one goes to the neutral point. The same is for low voltage side. For low voltage side, cables are different because they have this white coloring, and it's connected to this transformer. This transformer, you can see this is a tap changer simulator. So we will show functionalities of device with testing transformer with tap changer. Okay, I will now fix the camera here and record the application. I hope you can see it clearly. And now it's time to run some tests. Okay, so as I said, when you turn on device, this is the home screen. On home screen, you can see the test templates and results from before. And on this menu, you can change the version of application if it's needed. So you can change it here or here. Firmware and software. Of course, languages which will be available, and date and time. So now here we all gathered here to run some tests and see how device works. So I will press the new test, and now you can see the familiar menu, the familiar screen. Test info can be inserted here. When you press, for example, test purpose, you will see the pop-up keyboard when you can test, when you can insert some information for future reference, but I will skip this part. If you are user of some of our advanced series models, you are probably used to this feature. So you can select the test object, as this is the three-phase transformer. We will proceed with that. Configuration of device can be selected, and as I already said, we can go with automatic vector group detection. It's listed here in tests. We will press automatic vector group detection, press confirm, and select the test voltage. Test voltage, as previously said, can be one of these values. Because this is the smaller transformer, we can go with 10 volts here. We can save this template if we want, but we will save the later version of test settings, because when we select winding resistance measurement, it's kind of more complicated. So this is the test ready menu. This is only for automatic vector group detection. And now we start the test. Device runs the test. Here you can see, here in this white field, you can see, or I hope you can see, the device running testing all of the groups. And when the result is ready, you will see the configuration in this white field. So we wait a little bit. Measurement is ready. Test is completed. We press OK. And we can see in this white field, or I hope you can see, that the configuration is *n, *n0. If you cannot see in the white field, you can recognize this pattern here. So we accept it as it is. And now we proceed with measurement. As you can see, this is device remembered our previous configuration for test object. Configuration is now recognized. So there is no need to repeat this measurement. And now we select if there is tap changer at our test object. There is on load tap changer. We will press it. And now the device wants to communicate with us, asks a lot of questions, and now it asks us if how many tap positions are there. So we will say for this opportunity that there are 3 tap positions. Press confirm. Now device wants to know if the tap changer is on high voltage or low voltage side. We can toggle between these options, but it's on high voltage side. We'll test from first to third, and we can press confirm. Then we go through, we select the nameplate. On the first tap, we can select the value 180. On the last tap, it's 165. And the low voltage side is 25. Since it's our test object in our laboratory, I know these values, so we kind of rushed this part. And here you can change the tap position of the transformer. If you came to the field, you want, of course, to test from the first tap position to 25th, for example, and you came upon the transformer which is in 13th tap position, for example, you can go tap down, tap down, tap down until the first tap position. To enable this feature, you need to have this tap changer control cable connected to the tap changer box on the transformer. So this cable is part of standard accessories. Okay, we can edit all the taps. If we are not, of course, our device will recognize the values between first and last step. But if you, for some reason, want to change the position, change the value on some of the positions, you can manually do it. But we are happy with this because there are only 3 tab positions and it is okay. So we press confirm. We select the test. We want to perform winding resistance measurement. For now, press confirm. We go through test options. We can go basic and advanced. You can see here we can perform measurement on both sides, high voltage side or low voltage side. For this opportunity, we will do both sides. We will say operating direction can be changed here. It can be same or reversed. You see the change of the direction of these arrows. So for this opportunity and all load tab changer, commonly they use reverse because when testing transformer with on-load tab changer and measuring winding resistance, we always firstly test phase A, for example. We go to the last tab position, and then we don't want to move the tab changer position to number 1 and then perform measurement again. We can just continue from position number 25, for example. So don't waste time on that. Changing tabs can be automatic or manual. And temperature compensation can be enabled. Here we will compensate it to 75. And winding resistance recording can be again manual or automatic. We will select automatic and we will say, for example, below 0.6% for 3 seconds to speed up the measurement a little bit in this case. We confirm it. Test options, this is something we already did. We select the DC current, test current. It can be in milliamps or in amps. For this transformer, 1 amp is enough, so we'll select 1 amp. And we can save this template as winding resistance. You need to trust me that it's written here on the white field. Maybe you saw a glimpse of it, but this camera is kind of bugging me right now. So we go by trust. We press confirm, go next, then we can again see the test ready menu, check everything and press start. And at this moment, I'll sit in my chair and let the device do its job.
Dino, just move back a little bit your camera so we can see full screen. Yes, thank you.
I'm more than happy to help you. And now the device is doing its job, measuring. As you can see, as the device is connected, it changes tab position automatically. I don't need to go to the tab changer box. We wait until this value delta goes below our requested value. Device waits for a couple of seconds, 3 seconds. Is something I mentioned there in device. So after that, the measurement will be recorded and you can see written on the screen. You can see in this table that compensated value is already displayed. We are already at the phase B of the high voltage side. We are on the third position. Now we go back to position number 2. That's something I mentioned, the reverse way of testing tap changer. Now we will, in 5 seconds, we will be back to position number 1. I forgot to show you the safety strobe. It's working. It's connected here. I guess the whole screen is here. And high voltage side is tested. Now we switch to the low voltage side. Of course, we don't need to do anything. Device will do everything by itself. Low voltage side has a little bit lower value, so we will maybe need to wait for a little bit more time, but it's still acceptable. We are testing now phase B on the low voltage side. Finally, delta R value started to go down, and we will receive results shortly. And we have the phase C on the low voltage side. It was quick. Okay, test is completed. Press OK, and we can save these results. Again, we will give it a name, webinar. Winding resistance. We confirm and we leave it. And now before we start with turn ratio test, we will demagnetize the core. So we select the test, which is demagnetization. We press confirm. Test option can be 3-phase or single phase. We will demagnetize only 1 phase, although it's recommendable to do 3-phase, but since I don't want to bother, especially people from Asia, where it's late night, I will go with single phase, select the same test current, press next, and now we wait a little bit. If you can hear relays working, it means the test is on, and of course device shows that test is active here. So we wait a little bit until core is demagnetized, and the magnetization is completed right now. We press OK. And the last test for today will be turn ratio test. We will select test type, turn ratio, confirm it. Again, we will go with 3 top positions, the same. We can change this top position on nameplate. We will go down to position number 1. We press double times. We need to insert the nameplate values. Okay, turn ratio test. We have our configuration, test options. It's okay. And we select the test voltage, which can be 10 volts in this case. We go next. We can double check. We forgot to put deviation limit here. Pass-fail criteria. 5% is too much. Standard says 0.5. And since I have experience with this transformer, which is probably older than me, we can expect the huge deviation. And you will see that this value will turn to red color. You can see it here. Turn ratio result, phase angle results, and excitation current are shown. You can see that this goes pretty much quick with turn ratio test. We selected only sequential test to be performed. Device changed to top position number 2, and now we'll perform turn ratio measurement for top position number 2. And top position number 2 is done. We are moving to top number 3, and you can see this turn ratio test is really quick here. Phase A is already done. Phase B, and at last, phase C, position number 3. Test is already completed. We press OK. We can save it. If we don't want to save it, the device will warn us. Maybe you want to save it, and we can do it, or again tell him no. And this was the demonstration of currently available features of this device. Of course, you can see these results, or all of these results, saved on this device. It has 32 gigabytes memory. You can export the results on USB. And this is pretty much it about demonstration of this device.